This is lesson 6-5. We're still in chapter 6 talking about systems of linear equations. And now we've gone over all three types: graphing, substitution, and elimination. And we're going to start talking about how to know when to pick which one to use, right? So what do I mean by that? First of all, let's do a little review here. Remember that a system of equation has an answer, right? And it's either one solution, and if it's one solution, that solution is in the form x comma y. It's no solution, or it's infinite solutions, right? Infinite. I always leave out the i's. Okay, so a system of equation is going to have one of these answers, right? And no matter which of the three ways you pick, these aren't the three ways. Oh, my hands look awful. No matter, these are the three solutions, but there's three different ways to solve. And no matter which way you pick to solve, you're going to end up with the same solution. So we're going to do an example of that, right? So here, this is our system of equations, right? And we're going to solve it by graphing, and we're going to solve it by substitution, and we're going to solve it using elimination. And you're going to see that no matter which way we pick, the answer is the same, all three ways. Okay, so first of all, solve by graphing. First thing I want to do is put this in the form that's easiest to graph, right? So it can either be standard form, and you can find the x and the y intercepts, or it can be in y equals mx plus b form. I personally prefer y equals mx plus b form, so I'm going to put both equations in that form, right? So I need to change 2x minus y equals -4 to y equals mx plus b. So I want to try and get y by itself, okay? So I'm going to add y to both sides because I don't want it to be negative, so I'm going to add it to both sides. And then I want to get y by itself, so I'm going to get rid of this -4 by adding 4. So I'm going to have 2x plus 4 equals y, or if I think about it the other way, y equals 2x plus 4. Okay, and then my other equation was already in y equals mx plus b form, y equals 5x plus 1. Okay, so this is my system. I'm going to graph both of these and see where they cross on my graph, right? So for both of these to graph, I start off at the y-intercept. For this first one, it's 4. So on the y-axis, the one that goes up and down, I'm going to go up to 1, 2, 3, 4 and put a dot. And then from that dot, I'm going to move according to the slope. The slope is 2, or slope always has to be a fraction. So in this case, it's 2 over 1. So I'm going to go from this dot up 2 over 1, up 2 over 1, up 2 over 1. You can keep going on and on forever. And I need to get a straight edge. I'm just going to use another piece of graph paper and just kind of sketch a straight line. Okay, and then when I graph the other equation, y equals 5x plus 1, I'm going to go up 1 and put a dot because of this y-intercept. And then my slope is 5 over 1. So I'm going to go from this dot up 5 over 1. 1, 2, 3, 4, 5 over 1. Look at that. 1, 2, 3, 4, 5 over 1. So I actually already see where they share a common point. Oh, that was not a straight line. It was supposed to be. That was not a good job. All right, so they're supposed to cross right here at this point, had I done a good job of actually drawing a straight line there. So they cross right here. So this point is over 1 up 6, 1 comma 6. So you can graph both of these. You might have to change it a little bit. If we'd have kept it in standard form and graphed the intercepts, it would look exactly the same. And the two lines cross at 1 comma 6. That's our solution. So we would say solution 1 comma 6. It's the one point that lies on both lines. It's the one point that solves both of our two equations, right? It's the only point they have in common, so that's our answer. All right, so then let's solve it. So we know that's our solution, 1 comma 6. So when we solve it the other two ways, our answer should be 1 comma 6, right? So next I'm going to solve using substitution, and that's whenever I get one of my equations with a variable by itself, right? The best time to use graphing is when you see a system that has two equations that are easy to graph, right? So you shouldn't really have any, other than your slope being a fraction, you shouldn't have a y-intercept. That's a fraction. You don't want to work with, if these had crossed like in the middle of a square, that's hard to eyeball, right? It's a visual, this is the best visual representation. So when you've got super simple equations, they're both in y equals mx plus b form, there's no fractions on our intercept, and they cross at a clear point, 1 comma 6, they don't cross in the middle of a square where you have to guess where it is, right? That's the best time to use graphing. And we're going over all three ways because this entire lesson, 6.5, is all about picking which method is the best one to use to solve a system. So graphing is the most simple. It's probably the beginner way to solve. Once you get familiar with everything, we usually don't graph. We usually either use substitution or elimination. So it's like the beginner way, the most visual way, okay? So substitution. When's the best time to use substitution? When one of our variables is by itself on one side of the equal sign. Right? We've already solved for a variable. We haven't solved all the way because we don't know what the other variable is, but we've already got either x equals blah, 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 or y equals blah, blah, blah. Then you can use substitution. So once you have a variable by itself, you use that as your tool, right? So in the other equation, wherever I see a y, I'm going to substitute in what y is equal to, 5x plus 1. So I'm going to use 2x minus, and in place of y, I'm going to put what y is equal to, 5x plus 1. And the entire y value is negative. This negative sign goes in front of everything that's y. This is everything that's y, so I put it in parentheses. Okay, and then it equals -4. And now I've gotten rid of y and I've replaced it with something equal to y, but that has an x in it. So now the only variable I have is x, and I can solve for x. So I'm going to distribute this. This is really a -1, so I'm going to distribute that -1. So 2x, -1 times 5x is -5x. -1 times 1 is -1, equals -4. Combine like terms, 2 minus 5 is -3. I'm going to add 1 to both sides. -3x equals -3. Divide by -3. And x equals -3 divided by -3 is +1. Once I know what x is, now I have to solve for y. So I'm just going to go back up here and I can plug it into either equation. Doesn't matter which one I plug it into. I'm going to get the same answer for x no matter what. So the easiest one is going to be my tool, right? Y equals 5x plus 1. Now I know x is 1. So I'm going to say y equals 5 times 1 plus 1 because I just solved for x. Okay, so y equals 5 plus 1, which is 6. So then, of course, I have to list my answer, my solution, in x comma y form. X is 1, y is 6. Right? So my answer here was the same as my answer up here when I graphed. It's the same thing. It's just how easy is it to solve, right? So the best time to use substitution is when either x or y is already by itself, or if it's not by itself in either equation, but it's easy to get by itself. Like up here, if this equation, this bottom one, had not been that simple, if it had had other numbers, right, around it, but the top equation looked like this, would it be easy to get y by itself? Yeah. Add y on both sides, add 4 on both sides, boom, you've got y by itself. So if it's either one of the two equations, doesn't matter, one of the two variables, doesn't matter which one, x or y, is either by itself or easy to get by itself, then substitution's your best option. Okay, elimination. How do I know when to use elimination? If both equations are in standard form, or if you already have the leading coefficient to both of your y's or both of your x's, if they both match. Or if nothing else works, if graphing is not easy and substitution is not easy, your go-to, your like fallback is always elimination. That's kind of the one we use the most often. That's the easiest one to kind of manipulate to solve, okay? So here, in order to use elimination, everything has to line up, all of our like terms. So they either both have to be in standard form or y equals mx plus b form. With elimination, we usually go with standard form, right? So I'm going to get this in standard form, so I need to manipulate this equation. I'm going to subtract y from both sides and then subtract 1 from both sides. So I am going to end up, you guys can do that work on your own, minus y, so I'm going to have 0 equals 5x minus y plus 1, and then I got to get rid of that plus 1, so I minus 1. I end up with 5x minus y equals negative 1, and then on top, I kept it in standard form, 2x minus y equals negative 4. Okay, so once they're both in standard form and my like terms are lined up, do my x's match? No, they don't. Do my y's match? Yes, they do. Remember, the sign doesn't matter if it matches. It can be plus or minus or different, doesn't matter. The number in front of the letter, that's what matters. And in this case, there is no number, which means it's 1. Okay, so we can use elimination now. If the signs are the same, am I going to add or subtract? I'm always going to subtract if the signs are the same, if I want to eliminate them. So I'm going to subtract all the like terms. So 2x minus 5x, negative 3x, negative y minus negative y really means negative y plus y, which is 0. And negative 4 minus negative 1 really means negative 4 plus 1, which is negative 3. So we've eliminated the y variable. Now we can solve for x. Divide by negative 3, divide by negative 3. X equals positive 1. And once we use elimination to get one of the variables, then we just use substitution to get the other, right? And you can use either equation. This one looks the easiest. I already know what x is. I need to solve for y. Y is already by itself here, so I'm going to plug in x. Y equals 5x plus 1. I know x is 1, so y equals 5 times 1. This looks very similar to when we did substitution because the second step of substitution or elimination is the same. It's always substitution. It's kind of funny, right? First step in substitution, you substitute. First step in elimination, you add or subtract the equations together to eliminate one. The second step in both substitution and elimination is substitution. So they look the same. Okay, so y equals 5 plus 1, which is 6. So my solution is 1, 6. Okay, so we can see that our answer is 1, 6. There's only one right answer to a system of equations. You either get one solution, in this case we did, and we got 1, 6. You get no solution, right? If we were to graph that, they would be parallel lines. If we were to solve using substitution or elimination, we would end up canceling out our variable completely. It would just go away. And for no solution, the variable cancels and what's left over doesn't match. Like we would get 4 equals 6 or something like that. Doesn't match, right? So if that was the case for either substitution or elimination, if we cancel out a variable and we get something that doesn't match, that's no solution. Infinite solutions is when the two lines, when you graph them, they lie on top of each other, or when you're solving mathematically, the variable gets canceled out and what's left over does match, right? In either case, in either substitution or elimination, variable gets canceled out completely. In elimination, both variables would get canceled out completely, and all you would have left over would be numbers, and they would be equal. So in that case, it would be infinite solutions. So there's 3 ways to solve: graphing, substitution, elimination. There's 3 different answers you can get: one solution, no solution, or infinite, okay, for the same system. It's just giving you options, right? So here we are to the meat and potatoes, right? The important stuff of lesson 6.5 is deciding which system is best. So determine the best method. You have learned 5 methods. We actually learned 3 methods. They just split up elimination, that one method, into 3, right? So we have substitution, graphing, sorry, that's 1. Then we have substitution, that's 2. And then they split elimination up into elimination with addition, elimination with subtraction, and elimination with multiplication, right? And we've done all 3 of those. So that's just, we just call it all elimination. So those are our 3 ways: graphing, substitution, elimination. For an exact solution, an algebraic method is best. So if it's one solution, it's best to use substitution or elimination, not graphing. But you still could use graphing. That's the funny thing about this entire lesson is, yes, when you solve a system of equations, there's one right answer, whether it's one solution, no solution, or infinite. But in this lesson, it's asking you to pick the best way to solve, the best method. And really, it doesn't matter. It's kind of like your judgment call. It's subjective. Because no matter which way you pick, even if you picked graphing, you're still going to get the same answer, whether you graphed or substituted or eliminated. It's just trying to decide, in your opinion, which way is the easiest way to get to the solution. Okay, but again, it doesn't matter whether you're right or wrong, because if you pick the wrong method, you're still going to get to the same answer no matter what. Okay, so here, example, at a baseball game, Henry bought 3 hot dogs and a bag of chips, and he spent $14. Scott bought 2 hot dogs and a bag of chips, and he spent $10. Each of the boys paid the same price for their hot dogs and the same price for their chips. All right, they went to the same stand, paid the same amount. And the following system of equations represents the situation. So Henry got 3 hot dogs and a bag of chips for $14. Scott got 2 hot dogs and a bag of chips for $10. He bought less hot dogs, so he paid less money, right? That's our system of equations. So we have to determine the best method to solve the system and then go ahead and solve it. So since neither the coefficients of x nor the coefficients of y are adding inverses, then you cannot use elimination with addition. Okay, so that's just ruling out elimination with addition. We haven't ruled out elimination, right? Since the coefficients of y are 1, the number's the same, we can use elimination with subtraction, right? Since the numbers are the same, we know we want to use elimination, but the signs are not the same, so we can't add them together. We have to subtract. That's all it's saying. It's just breaking it down too much. Okay? We don't want to use substitution because neither equation already has x or y by itself. Yes, we could easily get y by itself, but why would we do that extra step when we can just start with elimination and we don't have to do an extra step, right? So in this way, both equations are in standard form, and one of our variables already matches. So we want to use elimination. Okay? And then which elimination to use you don't have to break it down that much. Just think, okay, I'm going to eliminate. Both of my signs are the same, so I'm going to subtract everything. Okay? So that's what they go ahead and do down here. You have your 2 equations. They're subtracting everything. So 3x minus 2x is x. Y minus y is nothing. And 14 minus 10 is 4. So they end up with x equals 4, right? Once you know what x equals, then you got to substitute to find y. So they went back into this original equation, and they plugged x in for 4. So 3 times x plus y equals 14. 3 times 4 plus y equals 14. That's 12 plus y equals 14, minus 12 on both sides, and y equals 2. Right? They just combined a whole bunch of steps here, okay? But they got x equals 4 and y equals 2. So their solution is 4, 2. Putting it in this form doesn't really matter since it's a word problem, because we have to know what does x represent, what does y represent. X represents how much hot dogs cost, and Y represents how much chips cost, right? So hot dogs are $4 each, and chips are $2 each. That's what this is telling us, okay? So let's try a couple exercises here. I won't do all of them. I'll do a couple of them with you. You can pause this and work on the other two if you would like, just for extra practice. Okay, so solving this problem right here, we're going to use elimination. We can't use substitution because we don't have any variable that's either already by itself or easy to get by itself. But if we use elimination, and we're not going to graph either because nothing's set up easy to graph. So we're going to use elimination. My x's are lined up, my y's are lined up, and my plain numbers. My x's don't match and my y's don't match, which means I'm going to have to use multiplication. And I can't multiply 5 by anything to make it a 3. I can't multiply 3 by anything to make it 5. So I'm going to have to multiply both, right? So it doesn't matter which variable I pick to make match when I have to multiply both. So I'm just going to stick with x's. I'm going to try and make my x's match. So I'm going to have to multiply this top equation by 3. And I'm going to have to multiply this bottom equation by 5. All right, so I'm going to distribute this 3 to all 3 terms. I'm going to distribute this 5 to all 3 terms. So I'm going to end up with 15x plus 3 times 3 is 9y equals 3 times 16 is 48. Okay, and then on the bottom, 5 times 3x is 15x. 5 times negative 5 is negative 25y. And 5 times negative 4 is negative 20. So now I can see that my x's match, right? They're both positive, so to get them to eliminate, I can't add them together. 15x plus 15x is 30. I want it to be 0. So I'm going to have to subtract everything. Okay, 15 minus 15 is 0. 9 minus negative 25 is really 9 plus 25, which is going to be positive 34y. And 48 minus negative 20 is really 48 plus 20, which is 68. Okay, and then if I divide this by 34 and this by 34, I get y equals 2. Once I know what y equals, I can go back up into either equation, doesn't matter which one, plug 2 in for y to solve for x. Okay, out of my 2 equations, I'm not going to fool with the top one because it has this big 16, and I want to deal with small numbers. So I'm going to use the bottom equation. I'm going to plug a 2 in for y. So 3x minus 5 times 2 equals negative 4. And then just simplify. 3x minus 10 equals negative 4. Add 10 to both sides. Negative 4 plus 10 is 6. So 3x equals 6. And then divide by 3, x equals 2. So my solution here is 2, 2. That's for number 1. And I kind of went down here in this space for number 3, so I'm not going to do number 3. Okay, let's do number 2. All right, looking at number 2, does it look like substitution's easy? Nope. Does it look like elimination could be easy? Yes. My x's, my y's, and my plain numbers are already lined up, and the number in front of y matches. So I'm going to use elimination, right? Easy enough. Now, is the sign in front of my y's, is that the same? No, it's different. So when the signs are different and I want to eliminate this, I'm going to add them. If the signs are the same and I want to eliminate them, I'm going to subtract. All right, 3x plus 2x is 5x. Negative 5y plus 5y is 0. And 7 plus 13 is 20. So I got 5x equals 20. Divide both sides here. I'm going to move this up. Divide both sides here by 5, and I get x equals 4. Once I know what x is, I can plug it back up in here to either equation. Doesn't matter which one. Plug it in, solve for y. So out of all these numbers, I got 3, 5, I got 2, 5, 7, and 13. That's a really big number. So when I start multiplying or plugging in, I guess, I don't want to deal with big numbers. So I am going to use the top equation. So I'm going to plug 4 in for x. So 3 times 4 minus 5y equals 7. 12 minus 5y equals 7. Minus 12 minus 12. That's going to give me negative 5y equals 7 minus 12 is negative 5. So then I'm going to divide both sides of my equation by negative 5. This goes away. Y equals positive 1. So my solution, when I put that together, is 4, 1. That's my final solution. That's what I want to get to. And then I started using this space, so I'm not going to do this one. Okay, so the solution to this guy, I used elimination. I had to use multiplication, and I had to multiply both equations to get one of my variables to match. And then since both variables were positive, I used subtraction. Okay, for this one, I already had a variable that matched, and they were different signs, so I had to add to get it to eliminate. And of course, once you use elimination to find the first variable, then you have to go back and use substitution to find the second variable, and you end up with an answer in the form x, y. Let me know if you have questions.